Hey guys, so my name is Joel. I'm gonna start this channel so I'm currently studying for my mcat, and some of my friends actually convinced me to do this. Hopefully it was a good idea by them, but I'm easily convinced, so I'm pretty excited to get this started. As the name is, Joel does Orgo. It's a little misleading because I will be starting with Orgo, but the goal is to actually do all of it, Sexology cars, all of it, like actually. And I'm hoping to get through all of it, but we'll see how well Orgo does. Orgo is my strongest subject, so there is a reason why we're starting with Orgo. So, no more introduction, let's just get started. So, the first thing before you even open your Kaplan book that you should know is formal charge, okay? So, there's a lot of different formulas for this, but I think this is the best one, humbly, obviously. So, formal charge equals valence electrons minus bonds plus dots, okay? So what do I mean by this, right? So by bonds, I mean the number of lines, okay? So let's try to prove this formula. So we know that carbon with only 3 bonds is positive 1. Now, we could memorize it, which I think you should. But to prove this is true, let's check it out. So valence electrons. Carbon has 4 valence electrons, okay? And here you see it has 3 sticks or 3 bonds and then 0 dots. So we will do 4 minus 4 minus 3 plus 0, and again that would get us positive 1. Simple. And then if we do that with this one here, so if we have a negative 1 charged carbon, we know 1, 2, 3, 4, 5, okay? So what we would do is we would do 4 minus 3 plus 2, and then that would get us negative 1. Okay, so this is both something you could memorize. Like, I would actually recommend to memorize this chart. It isn't too hard to memorize, but I will say I have actually gotten questions on my full lengths asking me to calculate formal charge. So it's a very easy question to answer. So I would learn this formula because, again, they could give you a lot of different type of molecules. So let's say I have something like this. So on the MCAT, they could ask you to calculate the formal charge of any of these atoms. But if we do oxygen, so we know the valence electrons of oxygen, as we see here, is 6. So we will do 6 minus bonds, which is 1, plus dots, which is, let's count out, 1, 2, 3, 4, 5, 6. So plus 6. So it'd be 6 minus 7 equal negative 1. So the formal charge of this is negative 1. Okay? Makes sense. Let's keep going. So yeah, it's a pretty, this is something that I think that, it's a pretty simple formula, and it's a good way to get points. I mean, this isn't a question you want to get wrong, right? So it's definitely a question you'll see. So next thing you need to know, especially for when we get to chapter 1, is these. So this is more of a memorization thing, but this is definitely something you should keep in mind because chapter 1 is all about IUPAC nomenclature, so we'll get there eventually. But you should definitely know all of these, the parent chain, the number of carbons. This is definitely something we've all been exposed to before, but it's always good to have a refresher. But this isn't something I could really teach, right? So this is something that you can go ahead, put on a flashcard or something. Use Anki, right? We always recommend Anki. But definitely, this is something you should know. I would recommend you know this before you open the book. Something else you should know is Lewis structure, condensed Lewis structure, and then bond line. So in organic chemistry, we're going to use pretty much only bond line, just because it's much easier to read. So let me explain bond line. So when you do a stick, right, we're going to call this a bond. You need to know each bond. So there's a carbon here, and there's an H, there's an H, there's an H. Okay. And let's say that we add another carbon. If you add another carbon, you lose H. Okay. So you usually don't draw in the H's. So if I draw this in bond line, it would look like this. Okay. So remember, you don't have to join the H's, but they are there. So there's an H there, there's an H there. This is something that we're all going to learn how to read when it comes to the MCAT because we don't really use Lewis structure, just not necessarily very useful. So when you're doing your exams, I would understand what this means and what to like how to draw it and how to comprehend it. Remember, every line is a CH3 group. Okay, that's one way to remember it. So this line here is really just CH3 bonded to CH3. Okay. And if we add another one, we lose a hydrogen, okay? Because remember, like we said here, carbon likes to make 4 bonds to be neutral, okay? So you can have 5, right? If you have 5, it's not possible, okay? The octet rule rules. The octet rule is pretty much saying that you can only have up to 8 electrons per atom, no more. So if you add 5 bonds, you have broken the octet rule, which you cannot do in organic chemistry. So make sure that you know that as well. So if we do this, right, this goes from CH3. Now we make that CH2, CH3. Okay? And we can keep going, right? So I'll do one more. So if we add this, we lose a hydrogen. The reason why is because we like 4. Remember that all the time. Every atom wants to be neutral. And again, I'll keep reiterating this. If we go back to your formal charge formula, to be neutral, carbon needs 4 bonds, okay? No more, no less. Well, yes, to be neutral, 4 bonds, no more, no less. So here would be CH2, but again, remember, these bonds are each CH3. So now it would be CH3. Okay? So this is something where I would learn how to read this, definitely, and then learn how to draw it, definitely, because this is definitely something that you will see all the time on the MCAT, guaranteed. Not as a question, but you will 100% have to know how to understand. Like, no question is going to ask you to draw a bond line, obviously, but you will be given structures that are in bond line, and you would have to comprehend what they are. This should eventually become second nature, okay? You can start out maybe by drawing your hydrogens if that's helpful, but I'm very against drawing hydrogens personally. I think it's just not necessary. You just need to understand carbon can make 4 bonds. Every carbon is a CH3 until you add more bonds to it. Every bond you add, you lose a hydrogen, you gain a carbon. Make sense? Awesome. So next, we should go over functional groups. So these are your general organic chemistry functional groups, right? So if you're taking an organic chemistry class, you should know all of these. But I'm going to definitely highlight the ones that we need to know just for the MCAT, okay? So most popular groups, you should definitely know what an alkane, an alkene, you should know a ketone, you should know aldehyde, carboxylic acid, ester, acid halide, amide. I don't really think peroxy. I'll circle it in purple. So this is like know about it, but don't know it as well as the ones in red. You should definitely know about anhydride. Alkyne is pretty important. I would say really that's about all of them. Definitely alcohol. Ether is important, but again, not as important. I think the amines are all sort of important. I don't think the coronary amine salt, ammonium salt that I've seen a lot, but that is something you'll see in organic too, just a class, but it's not something really big for the MCAT. I would definitely know your halides, but these are more for if you're doing SN1, SN2 reactions. So those are a little important, but again, the ones that are most important are these ones in red. I know it looks like I just circled all of them, but truly, like, the ones in red are the ones you see a lot, okay? Like, definitely all of these matter, but the ones in red, if you had to prioritize, if you're cramming right now and you're like, oh my gosh, prioritize the ones in red, okay? Awesome. So this we're not going to go too much into. I kind of want to save these for the Gen Chem ones, but this is hybridization. You just need to know generally something that has, so groups attached to central carbon. It's pretty much just saying how many bonds your thing is making. So a carbon with 4 is sp3, right? Because we just counted off. So 1, 2, 3, 4. Okay, sp3, 3 plus 1 is 4. Technically, this is, if this helps you remember it, there's actually a 1 here, but again, remember, we don't need to show it, but 3 plus 1 makes 4. If we have a positively charged carbon, and we do it like this, so I'm just gonna make these H's, there's no real reason why. Again, remember, this is a 1 here, so again, like we said before, 1, 2, 3. 2 plus 1 is 3, so sp2. Okay, and then if we have, let's say we have, if we have a carbon like this, again, this is a 1 here, and this is a 1 here, so 1, 2, 1 plus 1, sp. Okay, so this is something that, don't worry, we'll go into more detail, but definitely for Gen Chem. So this is really your fundamentals. Definitely knowing this is a good start, and if you understand these, you can definitely pick up on more things as we go on. So next, let's go to bonding. There is definitely, these are the main type of bonds you need to know for the MCAT. You definitely need to know your electronegativity. Now, you don't need to memorize the numbers, okay? Just straight up, you don't, but we need to know the trend. And especially we need to know these particular ones that are on here, specifically these 4 at the end, okay? Those are very important because, again, organic chemistry, we deal with a lot of carbons and oxygens, right? Organic chemistry. You need to know that the stronger the electronegativity, the more it wants atoms. You need to know fluorine is the strongest, okay? So a polar bond is pretty much when you have 2 uneven things. Like if we look here, fluorine and lithium, this is a polar bond, okay? Simply because the lithium is 3, the fluorine is 4 and the lithium is 1. So the electronegativity difference is 3. So that's going to be actually an ionic bond, right? If it's greater than 1.6, it's ionic. Between 0.5 and 1.5 is polar. Between anything that's 0.5 So that's definitely something you should know. It definitely helps to understand that. So between 0.5 and 1.5 polar, okay? But anything less than 0.5 would be nonpolar, and then everything greater than 0.5 would be ionic. Sorry, group is in May. Oh, okay. Anyways, I was gonna put those in order, but whatever. Yeah. So that would definitely help going on to these things. So usually an ionic bond is made between a metal and a non-metal, and this is again due to the electronegativity difference. So if we go back to this, we know fluorine is a non-metal and lithium is a metal. So the electronegativity difference is 3. 3, again, we said if it's any greater than 0.5, it's 1.5 is an ionic bond. So lithium, fluorine, non-metal, metal, ionic. Nice. So keep that in mind. This is going to be really helpful as you keep going and understand what different bonds are. So polar covalence, this is what I was saying. You have unequal sharing, okay? So an example of polar covalent would be here, okay? Fluorine and Be are polar covalent bonds. Again, because like we said earlier, if it's between 0.5 and 1.5, it's going to be polar covalent. And in this case, this is 2.4, okay? So what this is saying is the fluorine being more electronegative, we're going to say slightly negative, and this is slightly positive. So what's going to happen is we have something called a dipole. So that is when one atom is taking more electrons than the other, right? So the dipole is going towards fluorine. Because fluorine is more electronegative, fluorine is pulling electrons towards it, okay? Here's how I would remember it. Think of it like a tug of war. And let's say one side of the tug of war is pulling more. So fluorine, let's say fluorine has 5 people and Be only has 3 people. So fluorine is gonna be able to push it more towards itself, rather the Be obviously will not be able to compete. Okay, so that's what we call polar covalent. Now, a regular covalent bond is going to be equal sharing. So usually this is between obviously here, non-metal, non-metal and a non-metal, or a non-metal and a metalloid. So again, non-polar covalent would be 0.5. So something like roughly here, and fluorine, right? Because these two are equal to each other, and this is around like 0.5, 0.6. So this is going to be your non-covalent bonds. Sorry, your covalent bonds, your non-polar covalent bonds. Yes. Okay. And the next thing that we need to talk about is forces. So a few things that we need to know is there are different type of forces: London dispersion, dipole, hydrogen bonds, and then this all affects your boiling point. One thing you need to know is everything has London dispersion forces. Okay, there is no molecule that doesn't have London dispersion forces. Okay, when it comes to dipole, your dipole interactions are between polar. So do you see how here there's nothing here that has a dipole pole, right? Like we said earlier, this is carbon to carbon, right? So if we have a carbon to carbon, these two electronegativities are equal. So it's almost like having a fluorine to fluorine. So what's going to happen is this is going to be a non-polar covalent bond. When you have a non-polar covalent bond, you cannot have a dipole-dipole interaction. Okay, awesome. So next we look at THF, butanol, and then, so we look at these three. These three all have oxygens, right? And if we go back to here, these are oxygens connected to carbons, right? And if we go back to here, the difference between these two is great, right? So there's almost one, which is again between our standard of 0.5 to 1.5. So these two are polar covalent bonds. When you have a polar covalent bond, you have a dipole-dipole interaction. Okay, definitely remember that. Polar covalent bond, dipole-dipole interaction. And when it comes to hydrogen bonding is when you have a highly electronegative atom connected to an oxygen. So in this case, you have oxygen connected to a hydrogen connected to a highly covalent, highly electronegative atom. So not just OH. OH is one of them, but we also have HF. This is also hydrogen bonding. NH can also hydrogen bond, and again, OH can. So pretty much, these are your main three that we'll see in organic chemistry. So hydrogen bonding happens when you have a hydrogen connected to a highly electronegative atom. And like I told you guys earlier, we're really going to be focused on these four, okay? But what you need to know is hydrogen and carbon. So it's not on here, but just know the carbon is 2.5, and then hydrogen is actually 2.1, okay? So when these two bond, it's actually not a hydrogen bond, okay? And that's because there's only a difference of 0.4. And again, like we said here, if it's any less than 0.5, it's nonpolar. So when we look at this, these three are your highly electronegative atoms. So if you have a hydrogen connected to any of these three, you have a hydrogen bond. You can create a hydrogen bond. So the significance of this is the more intermolecular forces you have, the higher the boiling point. And this is definitely an MCAT question. And I will start it like this is like, please know it. Please, I beg you. Know that will show up on your exam. You should definitely know this. So as we can see here, the least intermolecular forces have the lowest boiling point. And then the most has the highest boiling point. And you might be asking, what is the difference between these two? And it's just the difference of a carbonyl versus a regular oxygen, okay? So this carbonyl, due to resonance, is more stable. More stable meaning higher boiling point. I hope that made sense for everyone. So, let's see. The last thing before we get started are arrows. So this is just a quick overview. I see this with my students all the time. Please get your arrows correctly. Few things, okay? Arrows never go to hydrogens. Never ever, okay? Arrows only go to, like, they never come from hydrogens like we see here. You will never have an arrow coming from a hydrogen. It just doesn't happen. The main reason is this: hydrogen has slightly positive characteristics. So there's no lone pair for it to like take something from it. So you will never have a slightly positive go to a negative charge. Because remember, when we use arrows, we're showing the movement of lone pairs. Okay? People that I've seen usually just move arrows just to move arrows. Like they don't know what we're doing. But you guys need to understand that when you're moving arrows, you're actually not just moving arrows, you are moving lone pairs. Okay? Like here, this is a positive charge oxygen, right? And we know this is a positive charge, like we said before, electronegativity. This is going towards the oxygen, making this oxygen slightly negative. So it doesn't make sense for this that has no lone pairs and no negative charge to try to pick up something with a negative charge. Rather, if you have a negative charge, your negative charge should go towards the positive charge, okay? Like we have right here. So your negative charge goes towards the positive, and then the lone pairs go back towards the oxygen, okay? You always want your lone pairs to go to your negatively charged. And like we said earlier, the dipole difference is favoring the oxygen. So this is very key. Please show correct arrows. And another thing is equilibrium arrows. This is just useful. This is just, again, more memorization. You should definitely, I'll just leave this here for a little bit. You should definitely just know this. This is just talking about what type of reaction that we have, okay? If you have an irreversible reaction, you can only show one very strong arrow. If it's reversible, you show back and forth. And again, like we see here, a really key one that really matters are these two. The difference between a arrow and then a fishhook arrow is, again, if you're moving one lone pair versus two lone pairs. Sorry, one electron versus two electrons, like we say here. So that's about it for chapter 0. I don't know how I feel about this video, so I have to watch it back and we'll see if I post it. But this is, again, the very first one. I plan to get a lot better. And yeah, definitely follow up the journey. So right now, my most recent FL was a 512. So I have about 2 months, and the goal, again, is 524. So let's see if we can get there. Definitely stay touched. Bye, guys.